Okay, we'll be talking about quadrilaterals. Quadrilaterals are four-sided shape like this, like rectangle, like square. So this is a rectangle. It has four sides. Two sides are equal. This side and this side, this side and this side is equal. This side and this side is equal. That's what they are telling you here. Now this is a parallel line. The parallel lines two are equal. AC is equals to BD. Here. Now, what you need to know here is just formula and how to apply it. We have parallelogram. Parallelogram is like this. It's different from rectangle. Rectangle is a straight line like this. This is a parallelogram. That's four sides to 1, 2, 3, 4. It looks like a kite. So PQ is same as SR is equal to SR or congruent that we're talking about. QR is congruent or the same as PS. That's what this is telling you. And PS is, yeah, that's it. This is another shape, trapezoid. Here, KN is parallel to LM. So I'm talking about parallel. It's parallel to this. I talked about parallelism the other time. And now this is the business. For all parallelogram, including rectangles, squares, the area equals the product of the length and the base, and the corresponding height. That is, the length of a base. It said area is equal to the product of the length of a base B and the corresponding height. So that means the area of the parallelogram is going to be height times breadth or breadth times height, BH. You need to know this formula, it's very important. So whether it's rectangle, whether it's square or parallelogram, this shape is a parallelogram. This is a rectangle and a square has all its sides equal. So that is the area. This is the area, base times height. Now let's move on. Let's see how this is applied. This is a rectangle. If you have to look for the area of this shape, it's going to be, this is the height. Base. You turn it upside down. This is the base and this is the height. So it's going to be base times height. This is the sorry. Let me explain well. Based on the way this thing is drawn, this is the base and this is the height of it. So base is 6, height is 10. So base times height. So that is why we have 60. For this shape too, this is a parallelogram. Don't forget. This is the height, 8. The height will always be like this. Draw the height from here. You draw it. Even if you don't draw this line here, you draw it from your brain. Imaginary line from here to here and here. This is form a triangle, but the height will be 8 and this is 20. This is the base. So the base is going to be 20 and the height is going to be 8. So that will give us 160. So you need to know these formulas. You need to learn how to apply it. The area of a trapezoid. This is a trapezoid. This is on this shape. The trapezoid. So we want to know the area of this. It's better for you to write that down. Just keep writing the formula down with each shape and learn it. So the area of a trapezoid is this: half into B1 plus B2 bracket close times H. B1 is the first base, second base is B2, and the height. Now if you look at this diagram, this is the first base, this is the base 2, and the height will be drawn from here to here, downward like this. This is not the height. LM is not the height. Don't mistaken that ever. The height is from here to here. The same thing with parallelogram. This is not the height. QP is not the height. RS is not the height. The height is going to be drawn from here down like this. So let's go back to our trapezoid. So this is the formula. So let's apply the formula. This formula here. So let's say this is the diagram of a trapezoid. So it has bases 10 and 18 and a height of 7.5. This is the base 10. This is base 18. Of course, this is longer than this, so this should be 18, this should be 10. And the height should be drawn from here down 7.5. So if you apply that using the formula half into 10 plus 18 times 7.5, that gives you 105. So that is that. All you need to do is just understand each shape, understand the formula for each shape, and that's all you need to do. Now let's go to circle. Now this is a circle. This dot at the middle of the circle is the center of the circle. A line drawn from the dot to any side of this circle from the middle is the radius. So OT is the radius. This is the radius. OS is the radius. Now it must be from the point from the middle. Now a diameter is an extended radius. For example, ST is the diameter because it comprises of two radius. So any line drawn from any side of the circle that passes through the center to the other side is called a diameter. So, and usually diameter is always equal to 2 of a radius. So that means 2 of a radius means 1 diameter. And PQ is a chord. That means a line drawn from any side of the circle to another side that does not pass through the center. So the difference between a chord and a diameter is that a diameter passes through the center while a chord does not pass through the center. That's all they are talking about here. Now we need to understand some things. We talked about distance, we talked about length. Now this circle has a length, and the name of the length is the circumference. So the distance around the circle is called the circumference, and there's a formula for it. You all know from Japanese school that circumference of the circle is equal to 2 pi r. 2 pi r is the formula. C circumference of the circle equals to 2 pi r. And how did you get it? C over d, which is the distance. The distance is equivalent to the circumference, equals to pi. So when you solve it, and your pi is going to be 22 over 7 or 3.14. So just know the formula. The circumference of the circle is going to be 2 pi r. So that's all you need to know about that. So if you want to apply that, for example, if a circle has a radius of 5.2, then circumference is 2 pi r. So 2 pi times what's our radius? 5.2. So to multiply that, 5.2 times 2 times pi, that gives you this 10.4 times 3.14, because your pi is the same as 3.14 or 22 over 7. It gives you 3.27. So there's no question about that. That is straightforward. Now, here's another. I'll tell you another thing about circle. I'll tell you about arc. Now, when you talk about circumference of a circle, talking about the whole length of a circle. We are talking about a portion of a circle. From here to here is an arc. Like a part of the circle that is not the circumference that is just like a part of the circle. It's an arc. So A and C is an arc. A, B is an arc. BC is an arc. In fact, C, D like this is an arc. Or if you want to take the other way around, the C, D here like this is an arc. So as far as it doesn't cover the whole circle, that means it's an arc. So it could be anywhere. If you read through this text, you get to understand the meaning of an arc. Now another thing I want to talk about is sector. Sector is this space here. So if you have an arc AC, an arc creates a sector. AC, this is the 2 points. I mean, this distance, this region, this 50% is a sector, 50 degree rather. So I think what I need to do, what you need to learn about this, is just for you to know the formula. That's all you need to know. In read through, you get to understand it. Now, we understand the total degree of a circle is 360, but for a sector has a portion. So this sector now is 50 degrees. Now, let me show you the formula. The length of an arc is a formula. Just know this formula. Theta over 360 times 2 pi r. That's the length of an arc. The theta will be the the angle created by the arc. In this case, is 50. So it could be any other thing. It could be 80, it could be 180, but it's going to be less than 360. You understand? So that's that. That's the formula. Write it down, and because I'm going to use it. Now, let me give you the formula for sector of a circle. It's similar to that of arc. The only difference is that we have pi theta over 360 times pi r square. Now this pi r square is the same as area of a circle, so you can say theta over 360 times area of a circle. But it's okay if you can just cram this, know this formula, theta over 360 times pi r square for sector, and for length, for arc, theta over 360 times 2 pi r. Now this is talking about distance. This is circumference. For example, let's just say theta over 360 times circumference of a circle. The same thing for length. We are talking about distance here. We are talking about area here. So just know these two formulas and know how to apply. That's all you need to do here. So all this story is just telling you how to derive it. At the length of an arc, we use the formula I gave you, which is theta over 360 times 2 pi r, right? 2 pi r. Now, if you look at it, using it with this circle, 50 over 360 times 2 pi, what's the pi? The pi is 5. So 2 times 5 is going to be 10 pi. Because if you solve it well, you're going to have 4.4. So what I would just advise you to do is this. So what they did was like length of an arc over 2 pi r equals to 50 over 360. So it's all the same, you understand? But if you just use the formula, you're going to get your answer straightforward. Understand? Now for a sector, the same thing applies. Use the same formula, theta over 360 times pi r square. R square, the r is 50. Sorry, the r is 5. So that's 5. 5 square is going to be 25 pi. So when you solve it well, you're going to get 10.9. I hope you understand this. It's simple and straightforward. You don't need to do any other thing. Understand? Now, a tangent of a circle. A tangent of a circle is this line that is drawing on the circle. This is the point. This point P signifies the tangent. So trace it from the central, from the middle, a radius drawn down like this. It's meeting, and it is a line drawn outside. So this is a tangent line, because this is a point. So when a line is drawn like this on a circle, it's going to create a tangent, because it's going to the radius is going to be perpendicular to it. So any line that is perpendicular to the radius like this is going to form a tangent. It's going to form a 90 degree. So this is a tangent line. So when you read through this, you get to understand what the tangent is. Now, I want to talk about how circles can be described, how shapes can be described in a circle. See, this triangle is inscribed in a circle. See another one inscribed. So see another one. This one, it forms 4 tangents, because see, 1, 2, 3, 4. So if we trace the radius from here to this place, it's going to be perpendicular. Another one from here to here, perpendicular. Another one to this place, perpendicular. Another one to this place. So this is 4 tangents. This shape is forming 4 tangents. So that's all about. This one is a concentric circle. When we have different circle, drawn inside one big circle. So that's all I want to talk about. So I will talk about this in the next video. 3-dimensional figures. Thank you.